Problem 1. A circuit is composed of an 8 Henry inductor and a 2 Farad capacitor. At time t equals 0, the capacitor is uncharged, and both devices have 3 amperes of current in them. A. What is the largest charge on the capacitor? And B. When does the capacitor have this largest charge? Please pause the video and attempt this problem. So let's start with part A. What is the largest charge on the capacitor? Since this is an LC circuit, we can say that energy is conserved, which means that the total energy stored initially in the inductor, because recall initially there is current through the circuit, the initial energy of the inductor is equal to the energy of the capacitor when it has its maximum charge. So we can say that the maximum energy on the inductor equals the maximum energy on the capacitor. Keep in mind, these will not happen at the same time. Again, the inductor will have its maximum energy at time t equals 0. The capacitor will have maximum energy later on. But if we take this equation and solve for the Q max, we cancel the 1/2 on both, move this c to the other side, and then square root it. We get that Q max is equal to I max times the square root of LC. Now you might remember square root of 1 over LC is omega. This is not a coincidence. But if we plug our values in, I maximum is 3 amperes times the square root of 8 henries times 2 farads, we get a maximum charge of 12 coulombs. So this is the answer for part A. The maximum charge is 12 coulombs. Now, how long does it take to reach that maximum charge? Well, let's go back to this diagram. We start here, and we go, the capacitor is maximally charged, the inductor is maximally charged, the capacitor is maximally charged but in the other direction, the inductor is maximally charged in the other direction, and then back to our original point. So basically we had to go 1 step, 2 step, 3 step, 4 steps, and I am skipping these intermediate pieces. But basically 4 steps where we go from one thing maximally charged to the other thing maximally charged to get back to the beginning. Which means that going from the inductor is maximally charged to the capacitor is maximally charged takes 1/4 of this cycle. In other words, 1/4 of the period. So we can find the period using t is equal to 2 pi over omega. We can find omega using omega is equal to the square root of 1 over LC. And we can say that the period of this system is 25.13 seconds. And so the time that it takes to get from maximum current to maximum charge is 1/4 of the period, or 6.28 seconds. Question 2. What would your answers to problem 1 be if there was an additional 2.4 ohm resistor? Please pause the video and attempt the problem. So adding this 2.4 ohm resistor changes us from a pure LC circuit to a damped LC circuit. Now with the pure LC circuit, we could figure out what the charge was by assuming energy is conserved. But as we can see from the damped system, energy is not conserved. So it might be better if we solve this problem backward, if we started with part B, because we can find our new omega easily enough. Omega is equal to the square root of omega naught squared minus alpha squared, and alpha is r over 2l. We have this information. So we can find omega naught, the square root of 1 over LC is equal to 0.25 per second. Alpha, the damping constant, is equal to r over 2l. We plug those values in, we get alpha is equal to 0.15 per second. This means we can use this formula, omega prime is equal to the square root of omega naught squared minus alpha squared, plug in these values that we just found, and we get that the new omega is 0.2 per second. So with this new omega, we can plug this value into our formula for period, get that this new circuit has a period of 31.4 seconds. And since we're looking at for when it's at 1/4 of the period, that occurs at 7.85 seconds. So the maximum charge on the capacitor will occur at time 7.85 seconds. Now, we could plug that 7.85 seconds into this full equation. And actually, we would have to be careful to use sine instead of cosine. Sine and cosine both work for this formula. We usually use cosine because we usually start completely charged. But in this case, because the capacitor started completely discharged, it started at 0, so we needed to use sine. But because we selected the point that was exactly 1/4 cycle away, we know that this term, the sine of omega prime t, will be 1 at this time, which means that Q is equal to the amplitude at that time. Now, from our results of problem 1, we know that the amplitude at time t equals 0 is this 12 coulombs. Now again, the capacitor never actually reaches 12 coulombs. That is hypothetically what it would be if it were fully charged at the beginning. But we can say that the amplitude is equal to that 12 coulombs times e to the negative alpha t. Alpha, we calculated, was this 0.15 per second. Time was 7.85 seconds. So we can plug all of those into this formula right here. Multiply the two terms inside the exponent first. Notice that the units cancel. You should never have a unit when you raise e to any value. So 12 coulombs e to the negative 1.178. Or the maximum charge that occurs at this time is 2.034 coulombs.